Something existed before the universe, not space, not time, not matter, something deeper.
Something unstable.
And then, without warning, it collapsed. That single collapse may have triggered everything. Every galaxy, every star, every atom in your body, even time itself. This changes the story you have always been told, because the Big Bang might not be the beginning at all. It might be the result. In this video, you are going to explore a hidden idea at the edge of modern physics. You will learn why the Big Bang does not actually explain the true origin of the universe. You will see how scientists are starting to question the very concept of a beginning. And you will discover a strange possibility that before everything, there was a state that could not even be called reality as we understand it. By the end, you will see why this idea forces us to rethink time, existence, and even the meaning of nothing. Stay with this, because the deeper it goes, the more unsettling it becomes. For most people, the story starts with the Big Bang. About 13.8 billion years ago, everything exploded into existence. Space expanded, matter formed, stars ignited, galaxies spread across the cosmos. It sounds complete, clean, almost satisfying. But there is a problem hidden at the very center of that story. The Big Bang explains how the universe evolved. It does not explain how it truly began. At the exact moment where everything is supposed to start, physics stops working. The equations break, the numbers explode into infinity. Density becomes infinite. Temperature becomes infinite. Volume becomes zero. This is called a singularity. It is not a real place. It is a sign that something is missing. When physics gives infinite answers, it is not revealing truth. It is admitting failure. This is one of the least talked about facts in popular science. The Big Bang is not a complete explanation. It is a boundary, a wall, a point beyond which current theories cannot see. And that raises a dangerous question. If the Big Bang is not the beginning, then what is? Scientists have spent decades trying to push beyond that wall, not with speculation, but with mathematics, quantum theory, and deep physical models. One of the leading voices exploring this mystery is Greene. His work focuses on the deepest structure of reality, space, time, and what lies beneath them. His research, along with others in theoretical physics, points toward a radical possibility. There may have been a state before the universe, not empty space, not darkness, not a void in the usual sense, something far stranger, a condition where space did not exist, where time did not flow, where the concepts of before and after had no meaning. This idea is difficult to accept because the human mind depends on time to understand anything. Every thought follows a sequence. Every event has a cause and an effect. But at the deepest level of reality, that structure may not apply. In quantum physics, nothing is. Not truly nothing. Even in a perfect vacuum, particles can appear and disappear. Energy fluctuates. Fields shift. Activity exists without a clear cause in the classical sense. Now take that concept further. Remove space. Remove time. Remove the stage on which physics normally plays out. What remains is not emptiness. It is a kind of raw potential, a quantum state that does not behave like anything familiar. And here is where things become even more unsettling. This state may not be stable. It could be balanced in a delicate way, like a system holding tension, like something waiting to snap. And then at some point that cannot be measured in time, it collapses. Not an explosion in space, a transformation into space. Not something happening within time. The creation of time itself. This is the idea that changes everything. The universe may not have started with a bang. It may have started with a collapse, a transition from a deeper state into the reality we now observe. This is sometimes described in physics as a shift from a higher energy state to a lower one, a release of energy that drives rapid expansion. But here, That shift is not happening inside the universe. It is creating the universe. That means space is not fundamental. Time is not fundamental. Even the laws of physics may not be fundamental. They could all be consequences of this transition. And if that is true, then the question, what came before, does not have a simple answer, because before might not exist in the way we think. This is one of the most overlooked ideas in modern science. Time may have a beginning, not just events in time, time itself. If time begins at this collapse, then asking what happened earlier becomes meaningless. There is no earlier, no past, no sequence. Only a state that does not fit into the categories the human brain is built to understand. And yet, through mathematics, scientists are starting to map this territory. They are exploring models where the universe emerges from quantum processes, from fluctuations, from instability, from something that is not quite nothing, but not something either. This is not science fiction. These are serious attempts to answer one of the oldest questions in human history. Where did everything come from? And the answer may not be a moment. It may be a transformation, a collapse that gave birth to reality itself. That is what you are about to explore. A journey beyond the Big Bang, beyond time, beyond the limits of what seems possible. Welcome to the channel. If you want to explore the deepest mysteries of the universe, make sure to subscribe and stay with us. The Big Bang is often described as the beginning of everything, a single moment where the universe suddenly came into existence. Space expanded, matter formed, energy spread in all directions. It sounds complete. It sounds final. But this story hides a critical flaw. The Big Bang does not actually explain the true origin of the universe. It only explains what happened after things began to expand. If you trace the universe backward in time, galaxies move closer together. Matter becomes denser. Temperatures rise to extreme levels. This part is well understood. The equations of physics describe it with precision. But as you go further back, something strange happens. The numbers stop behaving. At a certain point, the equations begin to break. Density rises toward infinity. Temperature becomes infinite. The size of the universe shrinks toward zero. This point is called a singularity. It is often described as the beginning. But in reality, it is a warning sign. A singularity is not a physical object. It is a place where the laws of physics stop working. It means the theory has reached its limit. It can no longer describe reality. This is one of the most important facts that many people do not know. The Big Bang Theory predicts its own failure at the very moment it is supposed to explain. At time equals zero, our understanding collapses. Gravity, described by general relativity, becomes too extreme. Quantum effects become dominant. But these two frameworks do not agree with each other under such conditions. They cannot be combined in a consistent way. This creates a gap in knowledge right at the start of everything. Scientists cannot say what actually happened at that exact moment. There is no confirmed answer for what existed at time zero. There is no verified description of how the universe truly began. This is not a small detail. This is the central mystery. Even more surprising, some physicists argue that time zero might not exist at all. The equations that lead to a singularity assume that current laws of physics remain valid all the way back. But this assumption may be wrong. New physics could take over before reaching that point. That would mean the singularity disappears. Not because it is solved, but because it was never real in the first place. It was a mathematical illusion. This idea changes the entire picture. If the singularity is not real, then the Big Bang is not the true beginning. It becomes a transition point, a boundary between what we understand and what we do not. This is why scientists continue to search for deeper explanations. They are not trying to replace the Big Bang. They are trying to go beyond it. The goal is to find a theory that works under extreme conditions, a theory that can describe the universe before it began expanding, a theory that removes the infinities and replaces them with something physical, This search has led to ideas that challenge basic intuition. Some models suggest that the universe did not start from nothing. Others propose that space and time themselves emerged from a more fundamental structure. Some theories even suggest that the universe existed in a different form before the Big Bang. These are not random guesses. They come from attempts to fix the exact point where physics fails. And that failure is not at the edge of the universe. It is at the very beginning of reality itself. Before the universe began to expand, there may have been no space at all, no distance, no direction, no place where anything could exist. Time may not have flowed, no past, no future, no sequence of events. Even the idea of a moment would not apply. This is difficult to grasp because every thought depends on space and time. Every experience follows a timeline, but at the deepest level of physics, those foundations may not be real in the way they appear. Scientists suggest that before the universe, there was a state that cannot be described using normal language. It is often called nothing, but that word is misleading. This was not empty space. It was not a dark void. It was something far more abstract. In quantum physics, even the concept of nothing behaves in a strange way. A perfect vacuum is not truly empty. It is filled with fluctuating energy fields. Particles can briefly appear and disappear. These are called quantum fluctuations. They are not rare. They happen constantly. Even right now, in what seems like empty space, tiny bursts of activity are taking place at scales too small to detect directly. This is one of the lesser-known facts of modern physics. Emptiness is active. Now take this idea further. Remove space itself. Remove time. Remove the stage where these fluctuations usually occur. What remains is not simple nothingness. It is a kind of raw quantum state, a condition where the usual rules do not apply. There are no particles, but there may still be underlying fields. There is no time, but there may still be change in a deeper sense that does not depend on a clock. This state could contain hidden energy. Not energy in the usual sense, but potential, the ability for something to happen, the capacity for reality to emerge. Some physicists describe this as a vacuum state with energy built into it. Others suggest it is a more fundamental structure where space and time are not basic ingredients but outcomes. One surprising idea is that space itself could be an emergent property, not something that always existed, but something that formed as a result of deeper processes. The same may be true for time. This means the universe did not appear inside space and time. Space and time appeared with the universe. That shifts the question entirely. The origin is no longer about matter appearing in a place. It is about a state transforming into existence itself. And here is where things become unstable. This pre-universe state may not have been perfectly balanced. It could have been holding energy in a delicate configuration, a kind of tension that could not last forever. Quantum systems are known for instability. Small fluctuations can grow. Tiny imbalances can trigger large changes. Even without time as we understand it, this state may have contained the seeds of transformation. At some level, it was not fixed. It was waiting. Not in time, but in possibility. And when that instability reached a critical point, something changed, not inside the universe, but into the universe. A transition from potential to reality, from no space to space, from no time to time, from a hidden quantum state to everything that exists now. The beginning may not have been an explosion. It may have been a collapse. Not something bursting outward into space, but something shifting into a completely different state. A sudden transition, a release of built-up tension that had nowhere else to go. In modern physics, there is a concept called a false vacuum. It sounds simple, but it hides something extreme. A false vacuum is a state that looks stable, but is not truly at its lowest energy. It is like a system stuck in a temporary balance. Quiet on the surface, unstable underneath. This idea appears in quantum field theory. Fields fill all of reality. They define the properties of particles and forces. But these fields can exist in different energy states. Some of those states are stable, others are not. A false vacuum is one of those unstable states. It can last for a long time. It can appear perfectly calm, but at any point it can drop to a lower energy state. And when it does, the change is sudden and violent. This is not just a small adjustment. It is a complete transformation. When a false vacuum collapses, it releases energy, a massive amount of energy, enough to reshape the structure of reality itself. Now apply this idea to the earliest state of everything. That pre-universe condition may have been a kind of false vacuum, not empty, but filled with hidden energy, balanced but not truly stable. For a time that cannot be measured, it remained in that state. Then something shifted, a tiny fluctuation, a small instability, enough to push the system over the edge. And then it dropped. This is the moment of collapse, not an explosion in space. The creation of space, not energy spreading into an existing universe. The formation of the universe through a release of energy. This turns the Big Bang into something very different. It is no longer a beginning in the traditional sense. It becomes a phase change, similar to how water suddenly turns into steam when it reaches a critical point, or how a stretched material snaps when the tension becomes too great. In those systems, energy is stored in a hidden form. The structure holds it in place. But once the limit is reached, the system reorganizes instantly. The same logic may apply at the deepest level of reality. The early state held energy in a compressed form, not inside space, but as part of its own structure. When it collapsed, that energy had to go somewhere. It became expansion. This could explain why the universe expanded so rapidly in its earliest moments. A period known as cosmic inflation. In a fraction of a second, space stretched faster than the speed of light. Not because objects moved, but because space itself was created and expanded. This is one of the most surprising details in cosmology. The universe did not expand into anything. There was no outside. The expansion was the unfolding of space itself, and it may have been driven by that initial collapse. Instead of a simple beginning, the universe could be the result of a release, a transition from one state to another, a shift from unstable potential to active reality. The Big Bang in this view is not the cause. It is the consequence, a visible effect of something deeper that changed state and reshaped everything at once. And if this collapse created space and energy, it may have done something even more profound at the same time. Time feels constant. It moves forward. One moment follows another. Causes lead to effects. This seems basic, almost impossible to question. But at the deepest level of reality, time may not be fundamental at all. It may not exist before the universe. In everyday life, time is treated as a background, a stage where events unfold. Physics once treated it the same way, a steady flow that everything follows. But modern theories challenge this idea. In extreme conditions like near black holes or at very high energies, time begins to behave strangely. It slows down, it stretches. In some equations, it even disappears completely. This is one of the lesser known results of advanced physics. Time can lose meaning. Now go further back, before the universe expanded, before space formed, before any structure existed. In that state, there may have been no time at all. Not slow time, no ticking, no sequence, no order. This creates a serious problem for intuition. Without time, there is no before, no earlier moment, no waiting, no process unfolding step by step. That means asking what happened before the Big Bang may not make sense in the usual way. The question itself may be broken because it assumes time already exists. Some physicists describe this using a different framework. They suggest that time emerges from more basic relationships. It is not a starting point. It is a result. In this view, time begins when the universe takes shape and that brings the collapse into focus again. That transition may not just create space and energy. It may also create time. The direction of time, often called the arrow of time, is linked to change. It is tied to the increase of disorder known as entropy. As the universe evolves, entropy increases. This gives time its direction, from past to future, but this arrow must begin somewhere. The collapse could define that starting point. At the moment of transition, the universe enters a state where change becomes possible, where events can be ordered, where one thing can follow another. Before that, there is no direction, no flow, just a condition that does not evolve in the way the human mind expects. This idea changes the concept of cause and effect, because it requires time. An action must come before a result. But if time begins at the collapse, then the collapse itself may not have a cause in the traditional sense. It does not happen after. It defines the framework where after becomes possible. This is one of the most unsettling ideas in physics. The origin of everything may not be caused. It may simply be a transition that does not need a prior event. Even more surprising, some equations in quantum gravity suggest that time is not continuous. It may come in tiny, discrete units, small steps rather than a smooth flow. This hints that time is built from something deeper, something that only appears continuous at large scales. If that is true, then time is not a background. It is a constructed feature of the universe, and it begins with the collapse. From that moment, sequences become real. Change becomes measurable. The past and future separate. But before that point, those concepts do not apply. There is no past waiting behind the universe. Only a state that does not fit inside time at all. And yet, something in that state still shifted. If the universe began with a collapse, then one question becomes unavoidable. What caused it? At first, this seems like a simple question. In everyday life, everything has a cause. A falling object, a burning star, a breaking structure. Something always comes before the effect. But at the deepest level of reality, this rule may not apply. One possible explanation comes from quantum physics. At small scales, nature does not behave with certainty. Events do not follow strict paths. Instead, they follow probabilities. Outcomes are not fixed until they happen. This randomness is not due to lack of knowledge. It is built into the structure of reality. Even in a perfect vacuum, fluctuations appear without clear triggers. Energy changes moment by moment. Particles can briefly emerge and vanish. This is not rare. It is constant. Now extend this idea beyond space and time. In a pre-universe state, there may have been no fixed direction of time, no external influence, no earlier moment to act as a cause. Yet quantum instability could still exist in a deeper form. A system that is not fully stable can shift on its own, not because something pushes it, but because it cannot remain in that condition forever. In this view, the collapse does not require a traditional cause. It may be inevitable once certain conditions are met. Another possibility is even more profound. The collapse could be governed by deeper physical laws that are still unknown. Laws that exist beyond current theories of quantum mechanics and general relativity. Modern physics already suggests that our understanding is incomplete. Quantum gravity remains unsolved. The behavior of space and time at extreme scales is still a mystery. So it is possible that the collapse follows rules we have not discovered yet, rules that determine when and how a universe can form. There is also a more speculative idea gaining attention in theoretical research. Multiple universes could emerge from similar processes. In some models, the universe is not unique. Instead, it is part of a larger structure where many universes form through repeated transitions, each one emerging from its own collapse. These universes may not interact. They may exist separately, each with its own space, time, and physical laws. This raises a striking possibility. Our universe may not be the only outcome. It may be one result among many possible results, like a branching system where different collapses produce different realities. In that case, the question of why this universe becomes even more complex, because there may be no single reason, only a range of possibilities governed by deeper rules. Some physicists even suggest that the idea of a trigger may be misleading. In a timeless state, there is no sequence of events, no moment where something starts something else. The collapse may not be triggered at all. It may simply occur when conditions allow it, not as an action, but as a transition that cannot be prevented once the system reaches a certain point. This removes the need for a classical cause, no external force, no prior event, no initiating moment in time, just a shift that becomes unavoidable within the structure of reality itself. And if that is true, then the origin of everything is not a single decision or event. It is a natural outcome of a deeper system unfolding into existence. If the universe began with a collapse, then the idea of a true beginning becomes uncertain. What we call the beginning may not be the start of everything. It may only be the first moment we can describe using time that changes the entire picture. For centuries, the universe was thought to have a starting point, a clear origin where everything came into existence from nothing. But modern physics suggests that this view may be incomplete. There may be no absolute beginning at all. Instead, the universe could be part of a deeper system, a process that does not start or end in the usual sense, one that moves through phases, transitions, and repeated states. Some theoretical models already explore this idea. In certain cosmological theories, the universe can go through cycles: expansion followed by contraction, creation followed by transformation. Each cycle producing new conditions, new structures, possibly even new laws of physics. These cycles may not be identical. Each one could differ slightly. Each one could carry traces of what came before or reset in a different way. This removes the idea of a single origin. It replaces it with ongoing change. In this view, the Big Bang is not the first moment. It is one phase in a larger system that is still not fully understood. This also changes the meaning of nothing. In everyday language, nothing means absence, no space, no matter, no energy. But in modern physics, nothing is not passive. Even empty space is active at the quantum level. Fields exist, fluctuations occur, energy shifts continuously at scales too small to see directly. This means that what we call nothing may still contain structure. Now, extend this idea beyond space and time. If the pre-universe state existed, it was not empty in the simple sense. It may have been a form of physical reality that does not match human intuition. A state with potential, rules, and instability. That means nothing is not the absence of reality. It may be part of reality itself. This forces a complete shift in thinking. Creation is no longer a moment where something appears from absolute absence. It becomes a transition between states of existence, a change in form, not a beginning from void. It also raises deeper questions about existence. If the universe comes from a collapse of a prior state, then reality may always exist in some form, not fixed, not permanent, but continuously transforming. This suggests that the universe is not an isolated event. It may be the result of deeper hidden processes. Processes that operate beyond space, beyond time, and beyond what current physics fully describes. These processes may determine how universes form, change, and possibly disappear. The structure of reality may be far more layered than previously thought, each layer governed by rules that are still unknown. And at the deepest level, what appears as a single universe may actually be one expression of something far larger and more fundamental. The Big Bang may not be the beginning of everything. It may only be the first moment we can observe, the first moment where physics starts to speak in a language we understand. Before that, something deeper may have existed. Not space, not time, not matter. Something more fundamental. a state that does not fit into our normal ideas of reality. And at some point, that state may have collapsed. That collapse could be the true turning point, not a creation from nothing, not an explosion into emptiness, but a transition from one form of existence into another. From that shift, everything we know emerged. Space began to expand, time began to flow, matter formed, energy spread, the universe unfolded into structure and complexity. But all of it may be a result, not a starting point. This changes how the origin of everything is understood. Time may not be the foundation. Space may not be the foundation. Even the laws of physics we rely on could be descriptions of what happens after a deeper transformation. In that sense, reality itself may be built on something we still cannot fully see. Every answer that brings us closer to the origin seems to reveal another layer beneath it. Each layer more abstract, more uncertain, more difficult to define. The idea of a final beginning starts to fade. Instead, there may only be transitions, shifts from one state to another, changes that create the structure of existence as a side effect. And the further science goes, the more this pattern appears. The universe does not give simple answers at its deepest level. It removes them. It replaces certainty with mystery. It replaces beginnings with boundaries. The true origin may still be hidden, beyond what current physics can describe. Not because it is unreachable, but because the framework needed to understand it may not exist yet. So the question remains open. Not just how the universe began, but whether beginning is even the right idea to use. And as this exploration continues, one thing becomes clear. The deeper reality is studied, the less certain any starting point becomes. If you enjoyed this journey into the hidden edge of the universe, consider liking the video and subscribing to the channel. There is still much more to explore, and the next mystery may change everything again.